on a happier note, can we do? And I think there are things we can do in the short term, and what we need to do, I think, is develop as a major commitment for the planet, as a Manhattan Project thing, a way of economically taking carbon dioxide out of the atmosphere. And it seems at first as if one shouldn't go for that, because since it's technology that's got us into this mess, if we try and do a technical fix for it, we'll probably make things worse, which could be true. But on the other hand, I don't see any other way of getting us out of this, the terrible consequences of global warming becoming as rapid as it is. So I'm pushing for, well, I hope there's other people pushing as well, for direct air capture, which is where you pump air through over catalysts or over chemicals which absorb CO2. You then liquefy the CO2 to put it underground or do something to it, turn it into some other material, and then continue the pumping. So this will be a massive task. And you sort of think, well, we can save ourselves by something yet to be invented. That sounds a bit kind of ridiculous, but in fact, it has been invented. That techniques that work have been developed by at least 5 different groups, and pilot plants have been built. This year, a pilot plant was built in Iceland using geothermal power to remove carbon dioxide from the air and pump it down into subterranean rocks where it reacts chemically with the rock. And that's a small plant, but it's working. It was a Swiss company did that. There's 3 US companies with different methods that they would want to try out. And so all of them have got methods which work, but which are too expensive. The break-even point is reckoned to be $40 per tonne, because that's the estimate of what CO2 release, the cost of it for the planet. It's an arbitrary figure, but somebody came up with it, and it's now regarded as holy writ. So if you can get rid of CO2 at less than $40 a tonne, it's a gain, so you should do it. Now, the trouble is that the companies that have developed methods, at the moment they cost about $100 a tonne, and that's very, very promising, because if we look at solar energy, for instance, solar photovoltaic power, that costs about 1% of what it cost 10 years ago, because of so much money was spent on developing solar that it's made it very cheap. It's made it cheaper than fossil fuels. So we could, if we spent enough money, we could do the same with these methods. We could get them cheaper so that they're less than $40 a tonne. So I think we can develop direct air capture that will work and that will be cheap enough. Then the problem then is, which one of the companies in the US has already withdrawn, because they said, yes, we've done this, but nobody's willing to pay for it. No government, including their own, and no company was willing to pay for the further development of a technique, because although it might cost in the end less than $40 a tonne, who's going to pay that $40? The people of the world have got to, the governments of the world have got to be prepared to pay to implement a system that works. And one sort of thought, when one thinks about the world, you sort of always think everybody wants the best for the world. But it's not true. I mean, there were lots of people who couldn't care less. And you can imagine how, say, if a nation that's elected, say, Trump, or in Britain, Theresa May, a nation like that might be, the people might in general be so selfish that they don't want to spend their hard-earned money on something literally pie in the sky that will clean up the atmosphere, and it will take years or decades to get rid of enough CO2 to bring the temperature down. So people will say, well, why should we pay for that? And you can see how there'll be a huge political battle to get direct air capture working. But it has to work and it has to be done, because I think that is our last chance. And that there are intermediate things, one of which I'm working on myself, which is geoengineering. And in geoengineering, you put a sticking plaster on global warming by increasing the amount of reflected radiation from the surface of the planet. So you cool the planet, but you don't do anything about CO2. So it continues to do its nasty work. It continues to make the oceans more acidic. And so all the bad consequences biologically of CO2 still continue, but at least the temperature effect is reduced. And the method there's two methods that are favoured. One of them I think is not good. That's releasing aerosols into the stratosphere. You have to get them up there by rockets or high-flying planes or balloons, and the powder spreads out in the atmosphere and lasts for months. It spreads around the whole world, stratosphere, then gradually falls out and has to be replaced. But while it's doing its thing, you can't control the effect. If this has some unusual effect, like affects the monsoon, well, you can't do anything. You have to wait till it's all come out of the atmosphere. So it could have very bad effects which can't be controlled. But the alternative, which is my favourite method, is called marine cloud brightening. And here's a sort of newspaper's view of how it will work. You have an unmanned ship with 3 tall masts, and inside the masts you have tubes where you're pumping seawater up to the top of the mast, and when it comes out the top of the mast, you inject it into the bottoms of low-lying clouds. That's the sort of stratus clouds that you get at sea for about 40% of the ocean, and over a lot of the land masses, like Britain is always covered with grey cloud. And it brightens the cloud, because if you use a fine nozzle for the seawater, it goes up through the nozzle, evaporates, and it produces tiny crystals, and the crystals get into the cloud and make the cloud whiter. The crystals have to be the right size, but there's an effect that's been discovered and measured called the Toomey effect, that if you take a cloud with droplets in it or anything in it, and the droplet size is big, then the cloud will be dark, like a rain cloud. But if you have the same amount of liquid in it, but in the form of very finely divided particles, like an ice cloud, then it's brighter. So the idea is to make low clouds more like ice clouds, not with ice, but with salt crystals. And it's been tested out and it works. So the idea is to have these unmanned ships drifting around the ocean, and you need about 300 or 400 of them, and that would be, and it's not that expensive, and that will be enough to hold back global warming, and while you use that time that you've got to do something more serious, like direct air capture. So my view is we probably need to do geoengineering. If we do, we should try something benign like marine cloud brightening, rather than something poisonous like aerosol powders in the upper atmosphere. And meanwhile work flat out to develop direct air capture. So with that, I think we can save ourselves if everybody's really, the whole world devotes itself to that, as if the world, for instance, if an asteroid was seen heading straight for Earth, the world would get together, would spend as much money as you needed to build all kinds of spacecraft equipped with nuclear weapons or whatever science fiction says you should do to divert this asteroid, stop it destroying the Earth. But global warming is like a slow motion asteroid threatening the Earth completely, destruction to the Earth. But we have time to do something about it, but at the moment we don't seem to have the will. But if we had the will as well, we could save ourselves by, I think, the direct air capture method. So that's my conclusions. I've got some time for questions. So that global warming will continue to develop unless we do something. Reducing our carbon emissions isn't fast enough and won't do the job because of the persistence of CO2 in the atmosphere. So we need to do something more drastic, and we need, I think, to remove carbon dioxide from the atmosphere directly and make that the new Manhattan Project for the planet. And in the meantime, we can try out this cloud brightening as a way of keeping ourselves cool while it all goes on. So that's my hope. So I don't feel we should give up hope, but I do feel all the things that are happening at the moment are bad. So we need to do this very urgently. So, questions? Yeah.
Can you comment on the situation in the Antarctic? Can you just say a few words about what's the situation in the Antarctic, and are there scientists studying over there?
Oh yes, there's a huge effort going on in the Antarctic. At the moment, the sea ice wasn't retreating in the same way as it was in the Arctic, but it's now started to retreat. And the biggest fear in the Antarctic is there's certain outlet glaciers from the ice sheet which are quite finely poised, that if they melt at the bottom, they come away from the seabed, and you get a big emission of water. So the fear there is that there'll be kind of jumps in global sea level produced by unexpected events in the Antarctic ice sheet. And that's why really it needs to be studied more intensely to improve the prediction of events which might lead to emission of water and increased rate of global sea level rise.
For your sea mist machine floating on the ocean, what would power those sea mist blasters?
Well, it's the designer of this is Stephen Salter, who's a brilliant engineer and was one of the early designers of wave power machines. So he always comes up with perfect blueprints. So he's ready to go. All he needs is somebody to give him a few million to start. But the way it would work is that the ship is unmanned, but those three tall masts you saw are actually Flettner rotors. That's a method of propulsion that was developed in the 1920s. They're rotating cylinders. It's actually wind power, but the rotating cylinder reflects the wind and gives you a thrust in a direction right angles to the wind. So you had Flettner rotor ships, and you have them now. Some ships, Japanese ships, for instance, have been fitted with Flettner rotors to improve their fuel economy. So he wants it to be 100% Flettner rotors, so it's wind powered, and then the pumping action, the energy for that comes from a turbine, underwater turbine, that draws on the difference in speed between the ship and the water. So it's entirely self-contained. There's no external source of power.
2 decades ago, on an airplane, I met 2 young men on the way to Africa with an idea to solve the drought, the extreme drought. And what they had done was created 2 bowls. It reminded me of the discs that you showed. And they were very, very light, to be made of the local material, so that would give jobs to the people around them. The bowls were to be placed on the freshwater few that they had, the freshwater lakes or ponds, and that would keep the water, the evaporation rate down, and at the same time allow sunlight, because there are discs and there's part for air to come in. And I'm wondering what it would be like to have these discs that you've shown also in a bowl shape facing down to stop some of the evaporation.
Yes, well, I heard a long time ago that something like that had been developed in Israel, but then I never heard any more about it. The problem is there's a group working actually in California at the moment, and I'm in touch with them to try to bring back sea ice. I mean, one of the things about this marine cloud brightening is that you can target a part of the world by instead of having randomly placed ships, if you place them according to a model of where the winds take the clouds, you can get the cooling effect focused on a particular area. And we did a study that showed that you could focus the cooling effect on the ice edge region of the Arctic. So you could have a subset of these ships could be aimed at cooling the Arctic and bringing back the sea ice, and then that would help you to survive or not have that big methane outbreak that everybody's afraid of. So that's targeting an area. But there's a lot of people who've come up with targeting the Arctic by putting white stuff all over the ice. And this group in California has that idea. You use a kind of fine, hollow-grained sand which floats and spreads all over the ice and the water. And I think it's unrealistic because of the scale involved. That you need to cover a few million square kilometres with this sand, so the cost will be astronomical, not to mention the fact that the sand's probably then eaten by the fish, so it makes the problem of plastic in fish stomachs a kind of minor compared to sand in fish's stomachs. So but the idea is you spread something on the surface to increase the albedo and get rid of radiation, get the radiation reflected. So I suspect this method with the bowls for focusing energy, it wouldn't work because of the scale you'd need. You'd have to have millions of square kilometres of plastic bowls, and the factories to produce them will be emitting billions of tons of CO2 every year. So the scaling factor usually kills off ideas like that, and there's very few of them survive into thinking about what can we try and make this work. Once you do the maths on costs and energy costs, it doesn't look good. Okay, any more questions? You've got 2 minutes and 23 seconds left.
At the personal level, here, at the personal level, what would you suggest that each one of us can contribute to avoid this disaster?
Well, I suppose it would be the normal things that you should do as good citizens too, in terms of minimising energy use and carbon emissions and so on. But the main thing, I guess, will be political, that you have to kind of urge your elected representatives to take this thing seriously. First of all, to take seriously the fact that we are being threatened by a slow-moving asteroid which could destroy all life on Earth unless we do something. And the thing we have to do is to find a way to get rid of CO2 and from the atmosphere, and we could do it if we just spend enough and take it seriously enough to do that. So it will be. There was a British science advisor to the government said, if we all did a little, the result will be a little, and it's a kind of cynical thing to say, but sadly true. If we all live as good citizens individually and do the best we can, the impact on the world is good, but it's not decisive. Whereas if we all get together and tell our elected representatives, you better do this, do something about this quick, or you're out on your ear, we're not going to vote for you anymore, then that might have a bigger effect. So I guess political activity would be the thing, but aiming it in the cause of saving the world rather than party politics. Well, that's great. That's good. Yeah, you have to. You could find a party that actually has an agenda like this and push it, but not many of them do.